This is the explanation portion of my week 1 problem set. Moving on to question 1, we were tasked with finding the marginal revenue and marginal cost of a certain function c of x and r of x. We were tasked with graphing the derivative of r of x and c of x. Looking at my Desmos graph I have provided, we can see that through this I have found that the bounds I'll be using will be 2254.307 and 0. We were then tasked with defining the meaning between the area of the curve. I thought that this was the marginal profit, or the place where we will find profit within our little model here. Going past that, I think we will go into loss. And for part 3, we were tasked with calculating the area between the two curves of the derivative of r of x and the derivative of c of x. I set up a standard integral equation with 2254.307 being my upper bounds and 0 being my lower bounds. I then plugged in my two functions with the derivative of r of x in the beginning, subtracted by the derivative of c of x. I then found the antiderivative of these two functions, plugged them into my upper bounds of 2254.307, subtracted them, and found that the answer was 509,065. Alright, moving on to question 2. This was asking us about finding a line C, which is a horizontal line that intersects the function of x, which is equal to 8x minus 27x cubed. I started off finding the first half of the area of the positive quadrant, which was 0.544 and 0. Through this, I set up another integral problem. However, just for my f of x function. So I found that half of c would be half of the area. So I put 0.54433 in the upper bounds and 0 in the lower bounds. Through this, I then found the antiderivative of 8x minus 27x cubed. And I followed through my integral and plugged in 0.54433 for x. Through this, I found half of c, which was 0.592592. I then doubled c, and that was my answer, which was 1.185185. Okay, moving on to the last problem. We were tasked with a standard interest rate and compound interest rate, I'm pretty sure is what it's referred to as. And we had to show the relationship between the beginning function and the end function and how you can derive this function from the beginning. So I started off on part 1, and I first found the natural log of both sides, or ln of both sides. I then simplified, putting the starting point of ln a of 0, subtracting that from both sides, putting that over to the ln of a point. I then applied my limits, which is n going towards infinity. Through there, I then found that I could divide by the reciprocal of n, which is 1 over n. Going on to the next page, part 7. I applied L'Hopital's rule and found the derivative of this function with the limit x approaching n. I then started simplifying, sort of getting rid of the doing the derivative of both sides, sort of doing it one step at a time. Getting rid of my n squareds on the denominator in the of my upper numerator there and my lower. Continue simplifying, and that I did found it to be true that A did equal AOE to the RT. I hope this was nice, and